there's a lot of really great choices out there for working with SQL data stores. Okay. And we've talked about a good many of them on this very show over the years. But today, this week, I thought we'd take things down a little bit, just go just a little bit further down the abstraction stack and look at data sources proper and their interplay with Spring and Spring Boot and some of the cool things you can do with them. So today, my friends, we're going to begin our journey, as always, here on the Spring Initializer, start.spring.io. We're going to build a new application. We'll call it DBs, and we're going to use Java 21. And by the way, friends, you should be using Java 21. Java 22 is almost here. You should be using Java 22 when it comes out, but at the very minimum, you should be using Java 21 because it supports virtual threads. Suddenly, so much of the sort of propaganda against a SQL database, that it's blocking and that it monopolizes threads and so on for scale, is sort of moot. Right now we have the ability to scale out that work. Now, of course, you have to hope your SQL data store itself can do the job, but it probably does, right? It probably can handle great scale. So there's a lot of reasons to use databases. They're versatile. They're SQL databases in particular, they're versatile. They handle lots of different use cases. I'm not saying they're the only data store you'll ever need, but they would feel right at home in a lot of application workloads, okay? And I've done videos on things like Yugabyte, and you've heard me talk at length about things like Postgres. I'm a big fan of Postgres, but there are many options out there. SQL Server, there's Oracle, of course. One that I just found out about the other day, DuckDB. And this is an in-process SQL OLAP database management system, kind of like SQLite insofar as you run it locally. But it's a full SQL database. It's super fast, and it's optimized for OLAP, online analytical kind of work, right? So really, really just interesting deal sport that's growing all the time. This is a fairly new project. All that to say, SQL databases are really, really interesting. So let's go ahead and try it out. We're going to build something with Postgres. We'll use the Docker Compose support to get it to give us the manifest that we need so we can stand up a Docker image. We're going to use Spring Data. We're going to use the Spring JDBC support, not even Spring Data, okay? Low-level stuff here. That's fine. And, just to keep things easy, we'll use H2 as well in case we want a quick database that's just in memory. Okay, so we've got a bunch of things. I've misspelled this. I'm going to call it DB. Okay, we're going to talk about this. We're going to go ahead and generate a project. Open this up in our IDE. And the first things first, before we can get too far down the road, let's take a look at the sort of basics of data sources. If you've used Spring applications before, if you use Spring Boot in particular, then you know it couldn't be simpler to configure a data source. You can just go here, Spring data source, URL, JDBC, Postgres, localhost, Postgres, etc. Right? And you can also specify the username. And what did the Docker Compose file that we were given give us, right? Compose.yaml. This is, database name is my database, the secret is secret, and the user is my user. The port is 5432. Let's actually switch this up a little bit. We're going to make this 5434 and map it to the internal port 5432. And we're going to call this, let's imagine we have two different geofence regions, right? EMEA and APEC. We'll change the port number here to be 5435, and that'll be 5434. All right. So we've got now two different SQL databases. They have exactly the same credentials, but different ports. Let's go ahead and run the Docker Compose up. All right. Now, Spring Boot can automatically run that for us. I actually selected the dependency on the initializer, and I don't want it to do that. I'm just going to let them run statically forever. So we'll disable that. Okay. So they're running in the background on different hosts and ports. We can confirm as much. And we're going to create some sample data in there. We're going to create a table called region metadata. And we're going to have a column here called region text not null. Okay. I'm going to say insert into region metadata region values APEC. Okay. Now I think that's right. Did we choose run 5434, right? And this is 5434. That's EMEA. Oops. Okay, so we want to do EMEA. Okay, quit. And then we can do the same thing for the other one, setting up APEC. There's no tables here. Let's, okay, this, and this one. All right, so now select all from region metadata, right? It says APEC for this one. Good. So now we've got two different databases, each of which has the same schema, but we have different columns, different data in those databases, right? We're going to talk about why that's important later, but it's also just nice to have that. So now we know we can easily connect to one of these by specifying my user and specifying the secret, right? Password. And of course, you should never, ever specify this password in your property file. I'm doing that because it's a demo, but don't do that. You want to have environment variables or HashiCorp Vault or something. Don't just check in the code with a secret in there, okay? All right, so we've got our connections. We've got our credentials. This is going to create a data source, a Java SQL data source, and that's fine. But what is a data source? Well, a data source is a thing that allows us to ask for connections to a SQL database. Data sources are made possible by drivers. These drivers come from JDBC, the Java Database Connectivity API. JDBC defines 4 different types of drivers. The first, and again, you probably won't need to know this. This is what's interesting. This is the kind of stuff I had to learn in the 90s when they're first defining JDBC, and it made a lot of sense then because JDBC was a brand new technology. So it made sense that the very first driver that they built was a bridge to a more entrenched database connectivity standard called ODBC. And if you've ever used, let's say, Microsoft Access in Windows, you've probably set up an ODBC database, right? You can do this in a cross-platform kind of way using different libraries, of course. You use native code for Windows, use native code for Linux, etc. But they all speak the ODBC API. And ODBC has been around for a long time, so there was originally a JDBC ODBC driver that was provided with the JDK. Apparently, and I didn't know this until researching this article, that was removed in Java 8 actually about a decade ago, right? In 2014. Happy New Year, by the way. And so this is now long gone, but it was my mistake. I was thinking this is still here. But there are apparently other vendors that have ODBC bridges. Not that we care, because nowadays there are just as many, if not more, JDBC specific drivers, right? But the very first one was type 1 driver. This is the bridge, okay? Type 2 is a native API driver. It's a database implementation that uses the client-side libraries of the database. The driver converts JDBC method calls into native calls of the database API. Now, here's my question. I don't remember the difference here. It's been 20 plus odd years. I'm not sure if this implies that when they say native API driver, if they're saying they're using the native Java API, and then that's not compliant with JDBC, and then they're just forwarding calls to that native Java library, or if they mean like it's Java code, it's JDBC Java class that is in turn using like JNI or something. I don't know. Maybe it's shelling out. Who knows what it's doing? But either way, it's an adapter. It's a wrapper around some other client library. Okay, so you've got 2 hops there. Not ideal, but it works. You've still got 2 hops in this first one as well, using JDBC to ODBC, and then finally you're talking to the SQL database. Okay, the third type is a sort of even more convoluted one. Here, you've got a driver that talks to some middleware running closer to the database. This driver isn't speaking the network protocol, but it's speaking the protocol of the middleware, right? And then the middleware can speak the protocol of the SQL database behind the scenes, or maybe it in turn sends the message to yet another driver. Who knows? But the point is that we don't have to care. Most of the heavy lifting, as it were, is happening in the middleware, in the server somewhere, right? And you're just acting as a client to that. So it's a facade for the client for the SQL database. It's a client to the client for the SQL database. And then finally, this is the one I think most of us are most familiar with. It's a JDBC type 4 driver where the Java code implements the network protocol of the SQL database so as to be able to talk to it, right? And certainly this is what I expect when I download a modern JDBC driver, right? I haven't seen or used any of these other types in years, right? But it's just interesting to know there is actually accommodations for all 4 of these types of different drivers. And drivers are the beating heart of the JDBC API, not data sources. In fact, you can provide an implementation of a driver for a SQL database without shipping a data source, because you can use the driver API to build up a connection and then use that connection to get to create a statement and then use the statement to execute queries, right? So if that's the case, then what good is a data source? Why does it exist? Well, data sources are aggregates or pools sometimes of drivers, of connections, right? So they actually provide a way to spin up new or reuse existing connections. Connections are what's precious, and each driver has to provide a way to create that. But the data source itself might be focused not on the underlying SQL database, but on the pooling of those connections, or perhaps auditing or whatever, right? Read and write checks, all sorts of interesting things that can happen on top of the connectivity implied by the driver. We're going to go ahead and take a look at that here. Let's go ahead and just build our first program. Okay, so just so we can kind of see what that looks like. Drivers configuration. Okay, just a configuration class. What we're going to do is we're going to create a little runner. We're going to call it drivers runner, and we're just going to inject that there. And here we can, when a driver is created, when the Java code for the driver is loaded, there's a static block somewhere that's calling register driver, passing an instance of the driver type. That driver you can then enumerate. So I can say get drivers right here, right? And you can visit each of them, right? So I can say as iterator.for each remaining, and given the driver, I can do stuff with it, right? Like this. Well, let's just see what drivers we get. Okay, toString. So restart the program. Okay, so we have an H2 driver and a Postgres driver. Great. So I don't want both. Let's just use the Postgres one. Okay, so let's say if driver instance of driver from Postgres, right? And then we'll restart that program, and you can see it's only showing the Postgres one. Great. Now, what can I do with that? Well, friends, here I can use the driver to create a connection. So connection equals driver dot connect, and here I would pass in JDBC : Postgres QL localhost, and then 5434 or 5435 / Postgres. That's the username. That's the database name. And then here I also need to pass in some properties, and these can be pretty consistent, but they're not standard. So you might get different ones for each different type of database here. So props, and the props that I'm going to pass in are user, and the user is called my user, and the password is secret. Okay, and of course this whole thing throws an exception, so we'll do that. Just add that handling there. All right, now I've got the connection. What can I do with the connection? Well, with the connection, I can create a statement, var statement. And by the way, you should be using auto closable and the like. The way that would work is you do var connection equals, and then all of this like that, right? Get rid of this. There you go. So that's, at least you're getting it cleaned up automatically when the scope things exit the scope. Now this is a little fragile, and but at least it's there. And this is one of those things where it didn't even do this much for years, right? You had to do it yourself. You had to have try catch and exception handling. Another reason to use something like the JDBC template, or more recently the JDBC client. Okay, so I've got the statement, and now I'm going to execute some SQL. So I'll say select all from region metadata, right? And what's the column name called? Just region, right? So I'll say var, well, we don't need to look at the results of that. We're going to execute that, and then we're going to look for the result set. So statement dot get result set. We should look at the results of that. It's a Boolean, but basically it only tells us if it succeeded. Let's just assume it did. Once we have the result set, we can say while next, and then we can get the next column. So string region name equals rs dot get string region, right? And then region is string region name, right? Restart. There you go. Look at that. Region equals EMEA for Postgres. So we're clearly able to connect to the database, and this is all pretty low level, but it does work. You can kind of understand what's going on. But it's imagine you wanted to change the password. Okay, so you want to probably keep that externalized, right? And what if you have more than one client? Well, they're going to want to connect to the same database at the same time, so you need a pool. And so we create this thing called a data source, right? Data source. And data sources are part of the JDBC spec, right? The copyright 2000, right? 2000. So it's not new by any stretch, right? But it only came around in 1.4. So there was other ways of doing this before that, but as a standard, it wasn't there for a long time. And you use DataSource to, it's just a wrapper, right? So it provides a standard connection object, connection pooling implementation, distributed transaction implementation. You might have a lot of different services that wrap your direct connectivity functionality, right? And so let's just hide this Spring Bean behind a profile, so it won't get run anymore, but we'll call this drivers, okay? We'll close that out. So we have data sources now, and Spring Boot will automatically create a data source using a connection pool for you. So earlier you saw me specify the configuration to connect to a SQL database here. Well, this stuff can also be used to configure some of the connectivity information. For example, here's my connectivity test query, select one, for example, for Hikari, okay? And there are other properties you can specify here based on the types that you've got in the class path. When this gets run, when the auto configuration gets run, you have DataSource auto configuration. What this does, let's download the sources here. What this does is it looks at your class path, right? And says, okay, you've got DataSource on the class path, great. And it creates a connection pool if you have these types and so on. And then it imports these other auto configs, one for Hikari CP, one for Tomcat, one for DBCP2, one for the Oracle specific one for the, what is this, C3PO, I think, which is generic. I don't know what this one is. And then Oracle, and then JMX, right? So basically, these are some connection pools. We don't configure all of them. We just do it based on what's in the class path. But I think by default, we ship Hikari. This is the one we recommend. There's also Tomcats. This used to be the default, I think, for a long time in Spring Boot, but we've since moved to Hikari. So if you look at that, that in turn creates a connection details object, which then gets fed into this right here, the Hikari data source creation. So this is creating a connection pool for you, ultimately using this connection details in that class and so on. And this in turn behind the scenes is using a data source builder. This is very convenient, and we're going to use this a number of times today, right? So we can just copy that code for our own use for later on. Okay, so I'm going to just, this is a little gross, but we'll just keep it there for later, okay? Don't need it now. It's just nice to know it's there, okay? All right, so that data source builder is from Spring, but it's just very convenient. You can give it the key information and it'll new up a connection pooled version of that connection for you. Okay, so we basically, if you have Spring Boot and you add a JDBC library and you add a Postgres, it's going to give you a connection pooled Hikari data source. You can use properties to influence that to create the data source, but you can also do it yourself. All right, so let's comment this out, and we're going to create another class here. Java data source configuration. Okay, this is just a configuration class. We're going to create a bean of type data source. And there's, if you're using H2, you might like our embedded database support. So return embedded database builder. Okay, dot build. And you can say what the type is, and the embedded database type can be H2 or Derby or HSQL. I've got that, right? And now, if you look at this data source, we're just going to inject it here. System out data source.toString. Okay, we're just going to inject it just so we can kind of see Java config db runner. All right, let's just run that. And you can see it's the embedded database factory. There's no mention of Hikari. So by providing this bean definition, we've overridden the one that would have been created here, right? Where we are taking precedence over this. And actually, I don't know what happens if we leave this here and leave the Java config. What happens? Yeah, it looks like our Java config took precedence. There are no other databases, no other data sources configured for us, even though we specified these properties. So you have the full control here. The rest, that data source will get plugged into the rest of the Spring machinery for SQL and Hibernate and JPA and Spring Data JDBC and MyBetis and JavaQ and all this stuff. It'll get plugged in automatically, just like you'd expect. Okay, so this is very, very convenient. What happens if you want more than one database? Well, let's say copy this. Okay, data source 1, data source 2, or I should have done that reverse, but whatever. So these two different databases, if I run this right now, it's going to break. Let's try it. Right? It's complaining that we don't have a primary database. We're not clear, and we didn't qualify it either. If I had used the same bean name here, then there would have been no doubt, and it would have been resolved. Right? That's fine. Or if I had just injected a map of string data source, right? I could have gotten all of the databases. System out data source.toString. Okay, good. So I've got all these different kinds of data source 2 is this one. Data source 1 is that one. So it's clearly working. But the thing I did was I just specified both, and I didn't inject it by qualification. And in that case, there is a way to make it work. So I'm going to just call this DB, which doesn't, you can use, even IntelliJ knows, hey, this isn't going to work. There's more than one bean of type data source, but you've asked for something that it can't resolve. So DB to string. And I'm going to say that this is the primary one. Okay. There you go. So it gets resolved even though I've got two. You've made clear to Spring's component model that you've got one that you intend to use. Now, this is a common enough thing that actually in some frameworks where we need an administrative database to keep track of the state of the ongoing application, like Spring Batch, there's actually a qualifier annotation called batch database. And this annotation is, it implements qualifier. You can add it to a database. And that way, if you want to use Spring Batch to manage a job that maybe it's moving data from Oracle to SQL Server, but you're keeping the administrative data for the Spring Batch job itself in Postgres, you annotate that one bean that is for Postgres with @batch DataSource. And that tells Spring Batch to inject just that one. It'll ignore the other two. You can use those other two for the actual jobs and steps and so on, but it's not going to try and store the administrivia of the job itself in SQL Server or Oracle. You're just going to be moving data in an ETL sort of fashion. This is very convenient. You see this pattern a lot in different frameworks that have more than one data source in play. There are ways to get around having more than one database when you're expecting just a single one, which brings us to the next thing. How do you configure multiple databases? Well, I just created a simple embedded one, right? But I'm doing all this like in Java code. Wouldn't it be nice if there was a way to do this using properties, just like we've done before here? Well, you can, right? So let's go back here, go to our Java configuration, and now we're going to change this a little bit. We're going to use configuration properties and bind them to some objects of type data source properties. Okay, so did you know that when you create a bean definition, you can still annotate the bean method and give it a configuration properties prefix? So let's say that we want to have one data source that points to EMEA. Okay, there we go. So return new data source properties. And we're going to do the same thing. I'm going to say EMEA data source properties. Okay, copy this, paste. APAC data source properties. All right, good. So now we've got this. So now this is a Java object. It's got a bunch of setters that you can use to specify the URL, the username, the driver class name, etc. And the convention is that if you just return an empty one of these, but you've got this on the bean method, Spring Boot will automatically map EMEA.name or EMEA.type or EMEA.driver class name to the object that gets returned from that Java bean method there. Let's go ahead and specify our connections. Okay, so EMEA dot. Okay, so now we've got two different bean definitions here, and we're specifying the configuration. And we've got these data source properties objects. Let's go ahead and use that to create the data source itself. Remember that static method that we stashed earlier? Let's go ahead and make that more of a real thing. Okay, so public static data source, create data source, given a few things, right? So we need the type here. So actually we can just borrow this data source, copy and paste all that. Okay, and then this is going to take a class extends driver. Okay, and then this is a data source builder. And the driver class name we can infer from that property, right? So driver.name. And we need a URL, so let's just pass that in as well. String username and a string password. Okay, so URL, username, password. All right, good. So we've got our method here. I'm going to just make this static because I'm a bad person. So @bean data source, EMEA data source, EMEA. So we're going to put the data source properties, EMEA data source properties. And return DBS application dot create data source. The driver is for Postgres. The type is Hikari data source type class. The URL we get from EMEA DataSource properties.determine URL. The username we get from determine username and determine password. All right. And then we need the class loader. I'm just going to default that to the system class loader. And voila. Okay, we can do the same thing now for APAC. All right, so we're going here. APAC data source. All right, so put all that here. Good. All right, so we've got now two different databases in our application. And we got to benefit from the configuration. It's a little long in the tooth because we have to create this thing first, and then create this, and it's fine. At least we can use configuration properties and still get some benefit out of it. Okay, so now if we go back to our application, our code down here, we've got one database. Let's fix that to have more than one database. Okay. There's this. And we'll say dbs.forEach key db d key equals, and then db. Okay. Let's just restart that. And there we go. Look at that. We got two different beans with two different data sources already configured for us. Let's actually debug this. So I want to look at this bit right here. And if I look at the DB that we have in scope, you can see that the username and the password have been configured. The driver name has been configured. Did I configure the URL? There it is, 5435. And we go again, 5434, right? So it's worked. We've managed to automatically bind properties to configure multiple data sources in the same Java app. All right. Let's hide this one. One of the nice things about this is that through it all, we're just using regular data source. We don't care if we're using a x80 distributed transaction capable data source. We don't care if it's using a connection pool data source, right? We don't care about any of that because we don't have to. It's just hidden through this nice abstraction that is the data source. And when you deal with Spring, through the magic of inversion of control and dependency injection, you can work with types in terms of their core super types, and that hides the details for you, which is what we want, right? And it turns out this can be taken advantage of. You can actually leverage this even further with a few particular kinds of data sources that are supported in Spring, or that have been part of Spring for, decades. At least 10 years for both of them, but almost 20 years for one of them. And those are two different kinds of data sources. The first is the abstract routing data source, and then we're going to look at the lazy connection data source proxy. So what is the abstract routing data source, my friends? Well, this type has been in Spring Framework since 2.0, which is like, 2006, right? So close to 20 years there as well. 2007 at a stretch. I mean, I think 2008 was like 2.5, right? So yeah, long time ago. The abstract data source implementation is meant for partitioning, for sharding, for routing. So imagine you have one data source object that is meant to be one logical data source, but you have a number of physical data sources, right? You can kind of see where this is going. I set up two different databases in my Docker Compose file, indicating two different geographies, right? APAC, Asia Pacific, and EMEA, Europe, Middle East, and Africa. And so you can imagine having an application that, for whatever reason, depending on who's making the request and where in the world they are, needs to talk to a particular database. There's all sorts of other use cases here as well. So the abstract routing data source gives you the ability to, based on some conditional logic, based on some key that you've placed in a context that you can discover where it's appropriate, route to a particular data source implementation. So it's not a pool of connections, it's actually a pool of data sources. It's a composite data source that lets you choose dynamically at runtime based on the request what data source to assign the request to. Why would you want to do this? Well, one reason is because maybe you want to have a read database versus a write database. Maybe you're doing a query where you want to read data from a database and you want to get you have lots of replicated standby nodes that can handle the read operations, but for the writes you want to go to the main node. Maybe you've got some sort of runtime framework that you've created where if you annotate a method with @write or something, right? You can create your own annotation that results in an aspect, an AOP aspect being introduced into your type, which when you call methods results in some sort of thread local being set. And then when this thing runs, when the data source gets used, it can inspect that key in that thread local and know which data source to hand back for the ongoing transaction in the current thread. Right? Simple example, right? Maybe you have at write and at read, or maybe you want to send a request to a particular geo-localized instance. Maybe you want Europeans to go to the SQL database that's hosted closer to them in Europe, and you want people in North America or APJ or whatever to get the more localized database. Or maybe you're just doing sharding, where you've got a UUID or something like that, or a bucket algorithm of some sort, where the modulus of every record or whatever, I don't know, whatever. But you want to do something so you can decide which data source to send the request to, right? It doesn't matter, especially now in the age of the cloud. There's all sorts of reasons why you might have more than one database instance that your application needs to know about, right? And you can hide that logic behind one of these things. So let's go ahead and do that. Let's create a simple thing where based on based on some queue that we give our abstract routing data source, it'll route the request to the EMEA data source or to the APAC data source. Okay, so routing configuration. Okay, and we already did the legwork. We already stood up the Docker Compose file that has those two different data sources. Let's copy and paste the configuration here into our routing data source code. Okay, there's this. And now we've got the two different databases. What I want to do now is I'm going to create my own abstract routing data source, static class, locale aware abstract routing data source. Implements or extends abstract routing data source. And all we have to do to use this is implement the thing that gives us the key, the lookup key. Okay, and where is it going to look for that? Well, we're going to create a thread local, a well-known place for the user to stash their current key. Right, so private static final thread local. And I'm using a thread local here because thread locals, they assume the current thread, right? And when you're using JDBC, you're typically on the same thread. Obviously, this is not going to be the same thing in the reactive world, but we're not dealing with reactive, so it's sort of moot. Okay, so current region, all right? New thread local, okay? And, we're going to have we're going to look at the current region, .get. Finally, we need to provide the actual map by key to data source, right? And so we're going to pass that in here like this, string data source. Okay, there's our data source map. And it's a little confusing, but basically it wants to target data source as a map of object to object. Doesn't really matter for now, but the point is we need to create that. Okay, so var new map equals new hash map object to object, and then we'll say dbs dot for each key db, and it's a new map dot put key and db. Okay, simple. This couldn't be simpler. Okay, and then we're going to pass that in here. Voila. All right, there's that. So we've done the hard part now. Let's actually wire this up. Let's create a bean of this type, and we're going to make it our primary one. Okay, so the one at bean at primary. And I'm going to say return new locale aware abstract database map dot of EMEA. We're going to inject the EMEA data source down here. Or APAC first, I guess, since that's what I discovered first. Data source. Okay, good. EMEA, APAC. Good. There's this. Okay, so we've got our two different data sources. The one data source. There we go. So now we got this one data source. This is the actual thing that's going to do all the work. Let's try it out. Okay, so I'm going to create a bean here, and region aware runner, and we're going to inject just the one data source that we just created, DataSource DB, right? And let's try it. We'll force our hand here. We'll say region.set is EMEA. And then we're going to say, and let's create a method here also. Let's do that. So given private string name, region name 4, and then given a data source, right? So DataSource DB. And we're going to create a JDBC client, JDBC client dot create db dot SQL select region from region metadata dot map that query rather integer dot single. Okay, there you go. There's our single results region name string. Okay, and we can just it's not an integer, it's a string, right? So we got that. This is an argument for Java OQ right there. Okay, and then we're going to return this. Good. So let's and actually I can just inline that, couldn't I? That's better. Okay, so now we set the current region to be EMEA. Now we can say system out region name 4 and data source, right? Okay, and then we'll do the same thing again for APAC. And we're going to print out the result that we get back. So therefore, they should both answer to the same query, albeit with different results. One has APAC, one has EMEA in it, right? I just realized I made a mistake. I'm going to put this in there. Restart. Okay, so we made the same exact request to the same data source, but we got EMEA the first time and APAC the second time, right? Now, this is a very trivial example, but hopefully you can see the possibilities. Imagine you're using Spring Security, which has its own thread local of a sort. It's its own sort of thread-bound thing called the security context holder. And imagine you've got your current authenticated principal with its identity, right? You can actually add extra information to that. It can be your own subclass of user details, for example. And then that you can downcast that and inspect it for information about the current user's whereabouts, country code, whatever, social security, whatever you want to use to bucket your data. And you can then use that as the key. Instead of using this public static thread local that I've used, you can use the Spring Security information as the key that you look up in the abstract routing data source, and then use that to determine to which data source instance the request should be routed. Pretty cool, huh? This is really, really powerful, and it's been in Spring since, like I say, just forever, right? This is one of those obvious use cases of a little bit of object-oriented programming and indirection and abstraction that really benefits people. And I just love Jürgen for doing all this cool stuff. I love Jürgen for doing this abstract routing data source. There's so many great examples of this throughout the framework of just using polymorphism to introduce new functionality seamlessly. It's all just data sources, but we've layered, we've adaptively added new functionality to those objects through this nice sort of polymorphic wrapper pattern. All right, so we've got the abstract routing data source. This is one of Jürgen's brilliant ideas. Another one that I quite like, and I'm going to look at here, is the lazy data source proxy. So let's go ahead and make this one. We're going to give this one a profile name here. Okay. Profile. And I'm going to call this routing. So now I'm going to create a lazy example. Okay. Close this. Lazy configuration. At configuration. Lazy. Okay. And the idea with this one, lazy data source, lazy connection data source proxy, the idea with this one is that the act of getting a connection actually steals or deprives your typical connection pool of one of the connections, right? And if each connection is backed by an actual socket, which represents resources and memory being used on the database server, you want to make sure that you're not just getting a connection for no reason, right? If you're doing like something where you eagerly need to get a connection in case, for whatever reason, in the body of some method, you want to do something against the database. So imagine using Spring Data JDBC or Hibernate or JPA or whatever, and in the context of a method, you've got the method decorated with @transactional, which tells Spring to, before the method starts, to start a transaction, and then after the method has completed, to commit or roll back the transaction. Well, if you're using the data source transaction manager, the JPA transaction manager, ultimately that means getting a reference to a connection, setting it to be auto commit to false, and then keeping it for the life of the method, and then committing when you're done. That way, any work done against that current connection is committed or it's rolled back. You've got a transaction that started. You're taking a connection from the connection pool, and yet there's nothing happening. You're just reading data, but that data is being, as often as not, served from the second level cache in JPA or from some sort of a cache manager in Spring. The Spring Data JDBC module works really nicely with a cache manager, for example. So I could talk to anything that the cache manager abstraction in Spring supports, and that could serve the results. So in this case, there was really no reason at all for me to have ever gotten that connection, because all the data is being fed based on a memoized key from a second level cache, and I'm wasting an actual connection in the connection pool to do nothing, which is a shame, right? And so the lazy connection data source proxy, what it does is it defers creating an actual connection into the very last moment, until you actually really need something that requires it, right? So you'll have an object that you can use that looks and walks and talks like a data source and a connection, but the connections are lazy. They don't actually result in a real connection being created until the very last moment when you actually start to need to do something. So let's take an example. The first thing we're going to do is we're going to create a database, right? Pretty straightforward. Let's just copy and paste one of the examples from earlier. Drivers, Java data source. Here we go. Okay, let's copy and paste one of the existing databases, okay? I wonder which one can I use? Maybe I'll just use this one. Let's just copy this code here, paste that here, and I'm going to create the data source manually. I'll just hard code the strings here. So JDBC Postgres localhost 5435 Postgres, my user, and then it'll be secret. Right? So just a simple database that we don't need. We don't need that data source. Okay, good. And this is a secondary data source. We're going to create a new one here, lazy connection data source proxy. I'm going to make this one at primary, so that when the question comes up of which one we're using that one. It in turn is going to use the other one though. So new lazy connection data source proxy. It expects a pointer to the actual one, which we can just inject like that, or we could inject it as a parameter. But either way, the result in this case, since they're the same name, is the same. All right. Okay. So one now depends on the other, but this is actually a data source. Right. I can actually cast this to a data source if I want to. Right. So I'm going to leave that there. And what this is going to do, like I say, if you look at the code, it's not all that hard. It's just sort of, it takes a year again to understand the brilliance of it, and really gifted engineers make hard stuff look simple. And that's what's happening here. This looks simple, and it is pretty simple once you understand what he's doing. But it's just a proxy. He's creating a brand new proxy of this type, connection proxy, and there's an invocation handler that gets involved. So when you call get connection, it creates this lazy connection invocation handler, and then this in turn caches the username and the password, and then invokes. If you call equals, it just does this. If you call hash code, it does that. It's doing the real work against the. It's doing as much of it without calling the underlying database as possible. If there is no target connection yet, then now we have to return a choose string, get auto commit, and then finally, if it's real, if it can't be handled locally with all those other tests, then we do the actual method invocation against the actual target connection, right? And here you can see it's going to great pains to avoid fetching it until the very last minute. Fetch physical connection from the data source. So get the data source to use, get the username, the password to get the connection, and then we have the actual connection. Apply transaction semantics, all this kind of stuff. But it's just pretty straightforward. It's just deferring to the very last second that, and it avoids wasting or depleting your connection pool of any of its resources. Remember, this is separate. It's orthogonal to the question of how many threads you're using. Even in virtual threads, even in Java 21 land, if you're keeping a socket open, that's a different resource than a thread, right? Sockets are actually pretty cheap. You can scale those up, but we're worried about how many concurrent requests your server can handle at some point as well, right? Your actual database server. Okay, so there's my actual lazy connection data source. Let's put it to use, okay? We're going to enable, let's comment that out for now, but we will enable transaction management. Okay, and then we're going to create a transactional service. So static class transactional service at transactional. Okay, and I'm just going to have two methods: void op and void no op. Okay, these methods are going to be transactional because the class is at transactional. I could put these on each method if I wanted as well, but why? I'll just put it at the top and it'll decorate all of them for me. And this will do something. This is actually going to do something. So let's inject the data source here. So we want the JDBC client DB, and we'll inject the data source, JDBC client.create DB. All right. And here we're going to actually do something. We're going to make a request. We'll say this.db.SQL select region from region metadata dot single dot query. I want a string class dot single, right? Sorry, no, I want that. I'm doing Kotlin here, friends. We want single. Okay, so there we go. We got the result. Okay, operation, and then no operation. All right. And so now we have the transactional service. I want to actually use that transactional service. I'll create another runner here to demonstrate. So application runner, transactional service runner, right? Return. I'm going to inject that here. ts.op and ts.noop, all right? So we're going to invoke both, and I want that transaction demarcation to be handled by a platform transaction manager implementation for SQL databases, the DataSource transaction manager, okay? So a lot of times this is just done for you. I'm just doing it explicitly so you can kind of see what's happening here. So I'm going to inject that by its type. This in turn gets invoked before every method is started. And you get an actual transaction, right? Connection holder, obtain a data source, get the connection holder, etc. All this stuff gets done before every method is invoked, and then it gets closed, committed after the method is finished. Well, that means we risk wasting resources, but have no fear because we're using this lazy connection data source proxy, which means that the connection we get back is just a no-op object. It's like a stub from a mock test. Okay. Now, it's going to be hard to see that this is the case, and I wasn't sure exactly how to show that to you. I mean, there is one way, right? The one way we can do this is to actually implement another bit of indirection, yet another proxy that wraps the lazy connection data source proxy with some advice so that when a method is invoked, we get a chance to see that it's invoked, okay? So this is going to be a little meta-programmy, but basically what I'm doing is I'm going to create a little wrapper around the lazy connection data source proxy such that whenever the get connection method is called, we see that it's called, okay? And this is I'm going to use a Spring Framework mechanism called a bean post processor. So get, connection bean post processor, turn new bean post processor. I'm going to do the one after initialization. And I'm going to say if bean instance of lazy connection data source proxy, then we want to replace it with yet another data source, right? And you can see we could implement all those methods, but I'd rather not. So what we're going to do instead is we're going to use the proxy factory bean, okay? New proxy factory bean, PFB, set target DB, PFB, set target, proxy target class is true, PFB dot get, set interfaces, is DB dot get interfaces, or sorry, it's DB dot get class dot get interfaces, and PFB dot add advice. I'm going to add a new method interceptor here. I'm going to say, okay, if invocation dot get method dot get name equals get connection system out get connection. All right. And otherwise, we're just going to continue as normal. So we're going to proceed letting everything else go through. This is just think of what I'm doing here as a listener for method invocations. When you invoke a method on the lazy connection data source proxy, we get callback and we can intercept it, so to speak. We can introduce some custom behavior before that method proceeds, and then we can tell the method to actually continue. It's a little meta-programmy. I'm sorry. It's the only thing I can think of that would make this work. So let's try it out. So if we understand everything, this is going to be a transactional service. It's got @transactional around it. When we call both of these methods, we should see get connection called both times, okay? But only one of them actually does anything with the SQL database. And you'll see that that's going to work. And you'll also see that this doesn't matter, right? You'll also see that we're only doing this work on the lazy connection data source proxy, not any other data source, right? So you can see that's the one that's being called. Let's try it out, huh? Let's just run this code. Oh, I forgot to define the bean, right, for transactional service. So bean transactional service. I'm going to pass in our database. Okay, I put in the wrong scheme. All right, oh, friend, this is silly. Okay, PFB, don't forget this part. Otherwise, it won't work, right? So I'm going to return the actual proxy. I'm going to tell Spring to use that proxy. There we go. So get connection, right? And then we got the result. Get connection gets called again, and then we got nothing. But again, the nice thing about this is that we're getting a lazy connection, right? So let's actually try that out as well. So here, and var result, and then we're going to return result no matter what. Okay, but here, system result dot get class toString. All right. So you can see we got a JDK proxy for the connection. All right. Pretty convenient, pretty amazing. This is a big deal, especially in highly contentious data access scenarios. Imagine using something like JPA or Spring plus JPA plus Spring and Spring Data JDBC or something where you've got lots of business logic. You don't want more granular transaction demarcation as you would get with a transaction template or whatever. I love this kind of stuff. All right, my friends. Well, that's that, huh? We looked at a lot of different things today. Hopefully you got something out of it. Let's kind of briefly review here. We started from the very beginning. We looked at how to create and configure a regular data source the normal Spring Boot way, spring.datasource.url. We looked at how to use the embedded database builder. We looked at Spring Boot's amazing support there. And by the way, it's worth mentioning. I mean, I didn't mention it because I take it for granted, but if you just use H2 on the class path and don't specify anything, you'll get a database. It'll create a data source for you. Right, and if you have H2 and Postgres, and you specify and you want to use a Postgres, just specify spring.datasource.url with the username and password, or optionally, and it'll give you a Postgres, right? And it knows how to determine based on the schema of the URL, the driver for a lot of them. It does an amazing job. So most people don't even know all this machinery is in play. We talked briefly about how Spring arrives at that actual final data source. First, it takes properties, or it looks at Docker, then it takes that and creates a connection details object, and then it uses that to create the data source using the data source builder. We saw that you can override these defaults by creating these data sources manually in Java code. We looked at configuration properties and how to bind them if you have more than one. We looked at ways of resolving conflicts when you have more than one data source in the application. We looked at things like connection pools. We looked at the history of the data source itself and drivers. We looked at the different kinds of data sources. And here I think is some of the most interesting opportunities, right? We looked at the XA data source for distributed transactions. I don't know if I would ever use that anymore, but it's an option. We looked at connection pools like Hikari. We talked about how Spring, by default, gives you a number of different connection pools for Hikari, Apache Tomcat, DBCP, C3PO. All these great different connection pools are supported out of the box, contingent on having the types in the class path. And then we looked at two of my favorite data source implementations going above and beyond from Spring Framework itself. The abstract routing data source, which makes it easy to dynamically route a request to a particular data source based on a context in whatever some sort of data in any context that you care about. And we looked at the lazy connection data source proxy, which defers to the very last moment the actual acquisition of the connection, so that you don't end up wasting or depleting resources in the pool if we're not going to use them, because, for example, the request can be served out of a second level cache. My friends, this is only the very beginning. And again, we're focusing on the low level stuff. We've just been focusing on data sources. I think I created like one JDBC client, right? And I could have used our old friend, the JDBC template. Doesn't matter, but that's certainly not a high level discussion of SQL or anything. This is all about data sources, and there's just a lot there. We looked at transactional and that brief interplay there as well. And I hope this made some sense too. I hope it was helpful. A lot of the stuff you kind of ended up having to learn when I was coming up and I was learning about all the stuff in the 90s and the early 2000s. This was all brand new. It just seemed like such a really, really interesting place to be able to play is around all these data access technologies. But now we are so, our cup runneth over, right? We have so many great options. We have so many options that sit above and beyond the lowly Java SQL data source. But that's not to say that that stuff should be ignored. My friends, thanks for tuning in, and we'll see you next time.